Hello, and welcome to your first tutorial on finite element analysis and modeling for ME372. In this tutorial, I'll first give a brief introduction to the finite element modeling process. Then I'll present a button click example using Ansys Workbench. Finite element modeling was developed to solve complicated problems. The process involves breaking a complicated problem into several simple problems. In finite element analysis, the governing equations are based on elements that have a finite size and shape. In conventional hand calculation analysis, such as using sigma equals mc over I and tau equals vq over it, the governing expressions were developed based on differential or infinitesimal elements. In this figure, the stresses in two mating gears have been computed using finite element analysis. The figure shows the elements that have been used to divide up the gears. The elements are connected to each other by nodes. The process of breaking the structure into nodes and elements is referred to as meshing. With computers being able to solve large numbers of equations simultaneously, popularity and capabilities of the finite element method have grown and continue to grow rapidly. Finite element modeling is used to solve all kinds of problems. This image shows the finite element model of a motorcycle that consists of hundreds of thousands of nodes. The goal of this analysis was to determine the natural frequencies and mode shapes of various parts of the motorcycle. This image shows the application of finite element analysis in modeling the function of the heart and using the analysis to predict function changes based on structural changes performed surgically. This image illustrates an area of multiphysics modeling called fluid structure interaction, where the effect on the stresses due to the flow over the parts of a race car are shown. As a mechanical engineer, no matter what area you specialize in, a solid foundation in finite element analysis and modeling will be very beneficial. Finite element modeling and analysis is something you will see, and although you may not perform the analysis or develop the models, you will need to understand the process and capabilities. I have received numerous email messages from past students thanking me for introducing them to finite element analysis. So take this portion of the course seriously and get excited to become a skilled finite element modeler. Finite element analysis consists of three major steps. These are pre-processing, solving, and post-processing. In pre-processing, we build the model. We create the geometry or bring it in from a CAD file. We assign material properties. We select the types of elements we want to use in our model, and we mesh the structure, which means we break it into nodes and elements. We then apply boundary conditions and constraints, and we apply the loads. Careful and accurate pre-processing is critical to obtaining good results. After the model has been built, it is sent to a solver. Solvers range from simple to very sophisticated. The solver will essentially be a black box for us, but the basic idea is that the equation F equals kx is solved for x, which are the displacements. In post-processing, we compute various results such as the stresses and strains, and we analyze these results. Ansys performs these three processes in a unique way. In Ansys Workbench, there is a main project schematic window where the model is outlined. This project window uses data from two software packages to build the model. The first package is SpaceClaim. SpaceClaim is used to create or import the geometry. Ansys Mechanical is the second package and uses the geometry from SpaceClaim to mesh the structure, assign boundary conditions and constraints, and apply the loads and send the model to the solver. It's also used for post-processing. Several very good tutorials on SpaceClaim and Ansys Mechanical can be found on the web. Be sure to include those names in the search. With this brief introduction, we will now open Ansys Workbench and look at the steps to developing a finite element model. When you open Ansys Workbench, this is the window that you will see. This whole window is called the project window. Up in the top, it will show you that you have an unsaved project. Once you name your project, it will change to the project name. Coming along the toolbar here, the file drop down is essentially the same as it is in most packages, where you can open, save, save as, import. This drop down here for scripting is where you are able to write code that Ansys Workbench will read, and we will talk about that in future tutorials. Under View, you can set up the windows how you would like them. You can show different toolboxes. One really nice feature about Ansys Workbench is you're able to customize your toolboxes and use the tools in the toolbox that you use all the time. Under Tools, you can look at the licensing and options. Under Options, you can come and set some defaults. You will typically not do anything with these options under Tools here. This is a higher level type of usage than we will typically be using in our tutorials for ME372. Units is an important drop down for us though. You need to make sure that you are using the right units or the units that you think you are using. And as we previously mentioned, Ansys Workbench uses two other packages, SpaceClaim and Ansys Mechanical. And the units in those need to be consistent. So always check your units to make sure that they are consistent from SpaceClaim to Mechanical to this workspace here. Under Extensions, there won't be anything that we use here under Extensions. This is a page where you can start the ACT start page, and this is another feature that lets you include scripting and extra code. If you get to advanced finite element modeling with Ansys, this is a great feature. And for some composites, for example, there will be extensions that you can add. And we may get to one of those tutorials. Under Jobs, it lets you open the job monitor and monitor the jobs and the progress of the solutions of these jobs. Under Help, you have the basic help settings that you can select. One thing that's great about Ansys Workbench is it is an extremely popular package, both by small end users as well as large companies. And there are numerous very good tutorials that can be found online by searching using Google or other search engines. These icons across here are to open files and save files. Typically you will use those often. You can also import a project once you've opened Workbench if you have a new project that you want to import the whole project. Again, this is the ACT start page. If you want to bring in extra code and extensions, you can use this. This toolbox is very important for us. It contains all the systems and tools that we will use to solve our problems. You can click on the little plus here and open up these different drop downs. And so for the analysis systems, here at BYU, we have licenses for a very large set of problem types. You can do static structural, which we will mainly focus on here in ME372. You can do acoustics. You can do modal acoustics and modal analysis. You can do harmonic response and harmonic acoustics. You can do all kinds of fluid flow. You can solve electrical problems, coupled field problems. Here we have transient structural, so loads that occur over a fixed time and a certain time, we can look at those. Transient thermal, turbo machinery. And so hopefully this gives you an idea of the vast amount of problems that you can solve using Ansys Workbench. Again, we are going to focus on static structural, and we will do a little bit of eigenvalue buckling, and we will do a little bit of topology optimization. All of these other tools are used by industry and are great tools to have access to. We will just not have time to cover all of them in this class. If you look at the component systems here is essentially a way to break down the analysis systems. So for example, in analysis systems, we have static structural. And in static structural, there will be a geometry module, like we have here, the geometry. There will be a meshing module. There will be a mechanical module. And so the component systems is simply a breakdown of these combined systems. I sometimes use component systems, and I sometimes use the full-blown analysis systems. Both are essentially the same approach. Under custom systems, if we open that drop down, these are very focused, detailed analyses on special systems, and we will not use any of these. Design exploration is an incredible tool. It lets us look at a lot of what ifs in our finite element models. You have parameter correlation, where you can change dimensions and see what happens to the structure if several dimensions change. You can look at optimization. You can do Six Sigma analysis. And so this design exploration is an amazing toolbox that lets us do a lot of high-end design exploration. ACT again is just another way to again look at these external codes and external extensions that we will not do a whole lot with in ME372. Down here you can click on view all of these and look at all of these systems in one setting if you'd like, or go back. This little identifier down here is really handy. You can see that it says it's ready, and we have the green light, so it's ready to continue on with development of a model. This will often turn red and tell you that your system is busy, and it will be busy doing solving or meshing or whatever the command will be. But if your system isn't responding and you're wondering why, look down here to make sure that it's not busy doing something else. We come over to this side and we have the job monitor. The job monitor, if you click on that, lets you bring up and monitor several jobs that you may have going on at the same time. I don't use the job monitor. No DPMS connection. If you click on that, what this lets us do is use multiple solvers and spread out our system so that we can look at distributed computing and do multiple jobs. Show progress. This is a handy tool. It opens up this progress window down here, and when you're running a model or solving a model, it will tell you the status of what's going on. Then you can show messages. You'll often get error messages and wonder what's going on, and this is where you can click on the messages and see the details of those particular messages. So hopefully that helps with the setup window in Workbench.